We're going to go ahead and talk about domain and range today. And the first type of notation we'll be doing is something called set notation. Okay, so just as a friendly reminder while you're writing this down, domain and range have to do with the input and output values of a relation or a function. We can see this in graphs, we can see this in word problems. Sometimes they just simply give us a list of ordered pairs and we can see it there. Okay, so before we go into any problems, I'm going to go ahead and put the format for set notation. Okay, we usually have a bracket, our X or Y, okay, some kind of line, and then we have an inequality. And for the sake of the general form, I'm just going to write inequality, and then we have another closed bracket. Okay, these things represent certain things. Whenever you see a bracket like this, you should immediately think of set notation, and that means that we're talking about, sorry about that, we're talking about a set. So another way to think of this is a list of something. Okay, most of the time it'll be numbers in our case. Okay, again, we start with the bracket, close with the bracket. Our X or Y, whatever goes here, okay, this represents what we're talking about. So in this set, we're talking about all the x's in the function. So this means for all x. Okay. One weird thing about set notation is this line here. This is something we use in college a lot. It can be a line or it can actually be two dots, but we're going to go ahead and use the line for our purposes. This stands for such that. If you didn't know, mathematics does have a language, okay? And so this is one of those language terms that we have that it's not an actual word, but it's a symbol that represents that. So far we have the set of all x such that, and then we have some inequality, okay? This inequality can be anything depending on what the graph or relation is showing. This is something that you learned in Algebra 1, okay? And it can be something, it can be as easy as x is greater than 4, or maybe a little more complicated where 0 is less than or equal to x is less than, I don't know, 10. Okay, so this is the old domain and range that you used to do many, many years ago. Okay, and we will be dealing with this inequality as well on another topic. So hopefully you got that. If you have any questions, please ask me in class. Okay, I'm going to go ahead and jump down to the first example. So go ahead and look at this graph. You should have it somewhere. Okay, and take a look at what we have. So first of all, you should notice that this is a discrete type of data. Okay, so this is discrete. That means that they're disconnected, and we're probably going to have a list. If this happens, domain and range is simple because as opposed to everything we did up here, all we have to include for this are curly brackets because there is no inequality to talk about. So we do our curly brackets. Let me fix that. We do our curly brackets. And let's say we're talking about domain first, okay? And because it's just discrete data, all we need to do is list all the numbers. So in this case, I would go to my x-axis, okay, so right here, go ahead and do that in a different color. I'm going to go ahead and look at my x and look at all the values that these points are taking. So for the first one, I have that this point is at 1, so I have 1. This one is at 2. This one is at 3. This point is at 4. This one is right on the line, so it's at 5. The next one is at 6, and that's where it stops. Okay, so in this graph here, our domain is from 1 through 6, and if you remember from yesterday, these are actually integers. You don't have to write this down, but if I wanted to write something on the side, I could say that x belongs to the integers because integers are the whole numbers, okay, in this case. Side note here, okay. Now, if I wanted to talk about the range, I do the same thing. I put my curly brackets because I'm using set notation, and set notation uses the brackets, okay? But now I'm going to be looking at the y value. So instead of going down to the x, I'm going to be going this way. So if I look at the first point, I'm going to go bottom to top. This one goes right here to -1. So my first point is -1, okay? The next one is one that people always get tricked on. This is the next point. Yes, it's on 5, but on the y-axis, it's actually at 0. So 0 is my next number, okay? Moving up to the next point, this one right here, it's at 1. Next one, this one is at 2. This one, 3. And finally, we jump up here, and if I go across, I see that it's at 6. And again, just like the domain, all of these are whole numbers, so I can say that x belongs to the integers as well here, okay? And this is our domain and range for this particular graph of discrete data. I'm going to go ahead and go down to another one. Go ahead and take a look at this one now. This one, by looking at it, you see that the points are connected. Yes, it stops here, but it goes forever in a direction. So this one is continuous. Okay. When we're dealing with continuous, we are going to have an inequality. So I want you to keep that in mind, write it down, or take a picture. We are going to have an inequality in our set. So right away, I'm going to go ahead and for domain, I'll put it here. I'm going to draw the little braces, okay? And I'm going to put that x such that, because this, and anytime there's an inequality, we do need to have this little fancy step here, okay? Same thing for the range, but instead of x, because it's range, I'm going to put y, okay? That's the first thing we need to do. Our brackets, our letters, and our little line that means such that. So let's go ahead and look at the domain first. Domain again is our x value. So for x, we need to look at the x-axis and see where is this graph starting. If I come to the left side, I can see that this point is at -2. So I know that it's starting at -2. Okay, I'm just going to make a note on the side for me here. And if I look to the right, I see that it has an arrow. In Algebra 1, you should have learned that an arrow means it's going forever in one direction. In this case, it's going forever to infinity. So when it goes forever to infinity, that means that x is going to be greater than something in this case. So I can say that x is greater than -2. Okay? Because at -2 we have a solid point, we can also say that it's equal to, because that point is included in the graph in this case. Okay? For the range, change colors, we look at the graph from bottom to top. So again, we start at this point, but now I'm looking at y, so I have -1 as my bottom point. And again, this is just side notes. And I'm going to go to the topmost point. Now, the topmost point in this case appears to be again an arrow. So that means it's also going to infinity. And so when it's going to infinity, we say that it's also going to be greater than some number. In this case, greater than -1. So y is greater than -1. And just like before, because we have that solid dot, we can say it's also equal to. Okay, and that is the domain and range for this graph right here. Moving on. This is the next graph you should have. Please forgive the absurd size of this. It just would not work on my screen. We're going to do the same thing here and find the domain and range. Notice that this is also continuous, which means we're going to have that inequality, okay? So for the domain, I'm going to go ahead and put my little braces here, put my x such that, okay, and my range such that as well, okay? And I'll come back to this in the next video.